Right, specific heat capacity. This tends to be one of the tougher concepts in the Physics 1, in the first part of physics. So, what does specific heat capacity mean, or SHC abbreviated to? Well, if you've got a big specific heat capacity, it means it needs a lot more energy to heat up that object, depending on its size. Obviously, if you've got a big object, it's going to take a lot more energy than a small object. But like for like, if it's got a big specific heat capacity, it takes a lot more energy to heat it up. So if they ask you to define it, you should define it like this. You should be able to quote this. It's the energy needed to raise 1 kilogram of matter by 1 degree Celsius. That is what we mean by specific heat capacity. There is a formula there. Energy is mass times specific heat capacity times temperature rise. And of course, you measure energy in joules. Remember to measure the mass in kilograms. The way they'll catch you out is by saying the mass in grams. The unit of specific heat capacity is joules per kilogram per degree Celsius. You can get that unit by rearranging the formula, by the way, later on. And the temperature rise in degrees C. Make sure you do say it's temperature change, temperature rise, or temperature drop. It isn't the final temperature, it's the beginning temperature, take away the final temperature, or the other way around. It's the temperature rise or change. That's what it looks like in a triangle. And of course, if you've got it in a triangle, you should be able to now work it out that E equals mc theta. Theta, that zero button at the top, that's the symbol for temperature rise. C is the symbol for specific heat capacity. M is mass. E is energy. Yeah, but theta is a new one. You've never met that before. Theta. And so you should be able to rearrange that formula to find out what M equals, what C equals, what theta equals. It's coming up next. There you go. So you can practice those if you wanted to make sure you fully understand those. How do we work out the specific capacity of an object? Very often this is a common question. What you do is you get a kilogram mass of the object you're going to investigate. Let's imagine it was, I don't know, aluminium. So you get a kilogram of aluminium. You put a heater in it and you put a thermometer in it, and you pack insulation all the way around it to make sure the heat goes into the block and you're not heating up the table or the air around it. So that insulation is important. If you haven't got that insulation, you're going to get a value that is too high for specific heat capacity. And you basically work out how much energy you've put into the aluminium block, measure the temperature rise, and that will allow you to then stick it in the formula to give you your specific heat capacity. You may be given a slightly harder practical, and there the way you work out the energy supplied to the heater is energy is the voltage of the power pack, the current supplied to it. So you'd have to measure that with a ammeter. That's shown by the letter I, by the way. I is the symbol for current. And T, little t, refers to time, not temperature. So the energy supplied is the voltage times the current times the time, and that'll give you the energy supplied in joules. And then you can use that value of energy to go back at, look at the other equation, E equals mc theta, and that will allow you to tell you what the specific heat capacity is. Here we go. Here's an example. Let's do this together then, folks. So you've got a temperature rise from 20 degrees to 50 degrees. So remember that the temperature rise. So you're going to take one away from the other. The energy supplied is 60 kilojoules. You need to work out what the specific heat capacity is. And we're doing this for a mass of 1 kilogram, by the way. Okay, this is for a mass of 1 kilogram. So write down the quantities of E, M, and theta. So your theta should be 30 degrees because it's gone from 20 to 50. That's a change of 30 degrees. You may have been caught out by 60 kilojoules. Kilo means 1,000, so that's 60,000 joules. And of course the mass is 1 kilograms. Stick those values in the formula, end up with an answer of 2,000 joules per kilogram per degree C. I've got some more examples up here, so you can spend some time practicing these now if you wanted to. And the answers are below, so if you want to pause the video now and practice it, you can. And the answers are there. Where you may have been cut out, I hope you did well on those. The way you may have been cut out is the top example where A, remember that is the temperature change. So the temperature change is from 20 to 45, so that is a change of 25 degrees C. For B, you shouldn't have been caught up by anything there. Oh, yes, you would have been. Possibly the 20 kJ, that's 20,000 joules. For C, you may have been caught out by the 100 grams. Remember that is 0.1 kilograms. And for D, you may have been caught out by 500 grams, so you need to know that is 0.5 kilograms. You must measure the mass in kilograms. You must measure the energy in joules, not kilojoules. Okay? And that is everything you need to know about specific heat capacity. Hooray!